Good morning, students. In the last lecture, you have learned two kinds of additional linked structure. One is a doubly linked list. So each node has a next and the previous. Okay, so they have two links. Each of the nodes have two links for the previous node and the next node, and you can go forth and go to the left and right very freely. And especially it is with your doubly linked list, it is easy to find an insert just before the current node. And another structure is a generalized list, which contains a list as an element. So the final um, list is very complex because the node data can be an element, atomic element, or another list. So actually this kind of generalized list is adopted a well-known programming language, Lisp. So if you once you take a look of the Lisp syntax, then you will find that uh, this is the essence of the generalized list. So then may be introduced in your programming language course. So we'll focus on today to the doubly linked list with a very simple algorithm, which is called insertion solved. So as you know, today's problem is extremely easy than anything else in before. So I prepared a bonus point for you, for most motivated students, because they want to solve further. They want to solve it and go further to the advanced topic. So, but it restates the iterator. So in the previous example of iterator, some of you have failed. Most of you actually failed to implement iterator. So I restated and how to implement it correctly today. So do you have any questions on the materials which was covered in the last lecture? No? Okay, then I'd like to switch to your handout of laboratory work, doubly linked list. So let me share my screen. So let me just resize it a little bit. So today's topic is doubly linked list. And for a singly linked list, you may have only forward scanning is easily performed. But with doubly linked list, the backward scanning is also possible. So scanning a linked list can be easily performed using an iterator. So it is saying that linked list with scanning, it is a piece of cake using an iterator. So defining type, as you know, the type determines the operator. Type determines the operator of some data structures. So defining type is defining operations. So for the forward iterator, you want to scan some structure. So you know that there's a linked structure here. So with the forward iterator, you want to reference this. You want to reference this, and you may go to the forward. So you may increment it. Okay, and eventually it goes to the null pointer, and then you may have to compare them either using this operator or this operator. Okay, so this is the basic operations for the iterators, either this one or this one. So you may define the iterator, especially the for iterator. The increment operator should be implemented for a for iterator. For instance, the following code is printing a stack using an iterator. So this is an example you have seen of in the problem solving section for your midterm exam. So as you know, node structure, node is not contained here, but you know that node pointer is available, and the node constructor is used here, so it is accepting a data element, and with the previous link, not previous, but it is a next link. So this is saved as previous because if you have a previous link here, previous stack top, and you'd like to push something, so you want to link like this. This is your new node. Okay, so you'd like to store n here and link the next to the previous. So the stack grows in this direction. Stack grows in this direction. So eventually this is a linked list from stack top to stack bottom. So sometimes you want to print all the elements inside of the stack. So you want to print so let me just recite it here. Here you can find that you want to print from the beginning. Begin means the stack top. So this is a stack top. From the beginning up to the end, you want to print the element. Okay, so here you can find some of the operations of iterator. The operation is assignment operator, and comparison, and dereferencing, and increment. So you have to implement 4 operations for the iterator in order to execute this print. So you have to define the iterator as a separate type. So you have seen that the iterator has a separate type here. The iterator. And as mentioned before, the assignment operator and comparison operator and dereferencing operator and increment operator. These 4 operators is currently implemented. So the iterator is initialized using a node pointer, and so it is just setting the current node pointer. So for dereferencing, it is returning the current data type. Okay, current data. So it is easily implementable. How about the increment operator? It is changing the current contents of the iterator to the next of the current. So it is not examining that the current is a valid pointer or not, but it is assuming that the current pointer is valid. So it goes further to the next point, and it resets the current pointer, and the result is returned as a node pointer. And for the comparison, it accepts another iterator reference, and it is comparing that the current pointer of this object, this iterator, is not equal to the current pointer of this reference. So the Boolean is just returned. See, assignment may be tricky because it should assign, it is accepting the reference of const reference of another iterator, and it is assigning the value of it, and it is returned current iterator as a reference. Okay, so with this simple setting, you may want to you can use the print, but additionally this is using begin and end, which is not the iterator operation but the container operation. So the container knows the beginning node and the end node. So it is a container operation returning the iterator. So the begin and is implemented by the container, and begin is easy because it just pointer stack top, which is the first pointer, and end is returning null pointer. Okay, so do you have any questions on these things? Do you have any questions? No questions? Then I'd like to switch to the Visual Studio Code and implement this. So others for push, pop, top is empty is implemented as before, just easily. So I want to switch to the PC screen. And unlock node new free list. This is for the level to the. Okay, so let me just switch it to. So I have to make lab open folder. Lab 8. Doubly-linked list. Double list. So I have to make a new folder. Lab 8. And add a new stack.cpp. And as you know, I have a pic of the previous code. So you have to implement class node. Class node is containing the element of data and node pointer to next. Data element to next, and it has a public method which is node. So the node is taking a data element D and the next element N. So the next element should be a node pointer N, and it should initialize data as D and next as N. So this should be empty. Class stack. And so you may want to declare that friend declaration stack friend class stack. Okay. and stack has a node first. Okay, and it has public methods for constructor stack. This is a default constructor. Actually, you can use null pointer. Null pointer is instead of none, which is a macro of null pointer. Void push int n. So I prefer null because it is a short. For you should typing just 4 characters. Node prev first, and first is actually new node, and the prev point is pointed by this new node. And void pop, assuming that the stack is not empty, first is first and next. And int top, returning the top data, return first the data. And boolean is empty. Empty is checking that return first is a null pointer. So up to here, you may want to implement all the details of stack operations, but you just want to implement print. So ostream reference print. Print is accepting ostream reference out. And for iterator, so you are defining using the iterator begin, and p should not be n. If it is not n, you may print the contents of it to the out stream. Contents of it to the out stream. So for the trailing space, just neglect for a while being and return out. Once it is performed out, you may return out. For the begin and end, you have to return iterator begin as the first element, return first. Iterator end, you should return null pointer. And the iterator should be implemented as a separate class, but I decided it as an inner class of nested class inside of a stack because it is specifically usable in a stack. So class iterator is implemented inside of the stack. So the iterator, you have to maintain the current node pointer. So it is essentially a pointer. And public iterator node pointer is a variable, but in default it is set as a null pointer as default. So in that case, the current pointer is set as node pointer. This is the default constructor. And for the next constructor, so next one is the assignment operator. Assignment operator, you should return the iterator reference operator, and the assignment operator is assigning that operator. What's wrong with this? So let's keep continue. So const, it accepts const reference of iterator, reference p, and the current pointer is set to p the current. So it is actually assigned and returned current object. And Boolean operator comparison. So it also accepts a const reference iterator const reference of it, and it is comparing return this, that current pointer is compared with p.current. And integer operator dereferencing is returning the data, which is an integer. So as you know, this is a unary operator. It does not accept any parameter and return current data. And finally, node pointer is returned from the operator plus plus. As you know, this is also a unary operator, so it does not accept an argument. This is a postfix plus operator, increment operator. So current value is set as current next, and that value is returned. Okay, so it is returning the value after the increment. So this is correct. So you have implemented stack type here, and your main function, inside of a main function, you want to build a stack S, and you want to push some of the integer elements, so LMs, NS. So the integer elements may be 1, 2, 3, 4, 5. Okay, and you want to push it into N in NS, push it for the stack. So stack S that push an element. Okay, and you want to print the contents of it. So you want to as that print, so it is correctly pushed or not. Print. So it is starting from the stack top, okay, to the cout, which is upstream. So in order to use cout, you have to include IOStream and using namespace. Cout print. What's wrong with this? Print. So let's take a look. Stack has no member print. Why? It has a member print here. Begin. This is, there's something wrong in the previous. Semicolon is not attached to the iterated declaration. So that's the reason. Okay. How about this node? No instance of constructor node matching previous P. So P is wrong. N should be transferred. Is this int unknown type priv? This is wrongly typed priv. So it is good. Okay. So let's test this using, so let's build it. Before that, I want to just show you there's a package which is called Code Runner. So in my case, I just installed a Code Runner, and it is containing that it is running for code for C and C++. So this is very convenient rather than build a script for everything every time. So we just after installing the Code Runner, you can click the run code here. So can you see 5, 4, 3, 2, 1 is printed. So you may want to print it every time for push. So just move this here. then you can check it every instance of print for every time. So let's execute this with code runner. But every time for cout you have to print end line, so for which is more readable. So can you see that 1 is printed for pushing 1, 2 1 is printed pushing 2. Okay, so you can take a look for every time. But you know that this may be tedious for end line for every time. So you want to give it end line. Okay, so let's just, you want to give it end line for if it is the last element. So if you want to do that, you have to compare that p plus 1, if p plus 1 is the end, then it's not end, you want to print this. If it is not, you want to print new line. Okay, so what about this? You are comparing that if p plus 1 is not end, then print a space, and if it is end, you want to print a new line. Okay, then you don't want to use end line here. Okay, since every print of the stack will be terminated with a new line character. But in order to do that, you have to implement, can you see the red underscore here? You have to implement plus as additional operator, so which is a binary. So int operator plus accepting an integer delta. Okay, then you want to you have to assert that delta should be positive or equal to 0. Okay, in order to use assert, you have to include C assert. Anyway, so once this is asserted, then you know that delta is a positive integer. Then while delta is positive, you want to return, it is not an integer, you have to return node pointer as a result. While delta is positive, you want to scan it, node, the current is set as current. Okay, so the node pointer is set as current, and you have to increment it to the next. P equals the next. Why this is wrong with node? Expected assert. Okay, sorry for assert. So you have to go forward of the next and then return P. Okay, this is the meaning of the plus. So plus 1 means take just one next. Plus 2 means follow next and next. Okay, so you want to return that without altering the current iterator. So with this matches no operator. Why it is not matched? It should be. It should not be the node pointer. It should be an iterator. Okay, so that is the reason. Iterator. So for the iterator, So, but this is valid because the iterator is accepting a node pointer, so it is making a new iterator here. So it is good. Okay. So with this setting, you just run code, but you know that there's no trailing spaces after that. You know that you can see the trailing spaces at the end of every one here, but there should be no trailing spaces once you execute this. But it is wrong. Ah, okay. Thank you. So delta should be decremented. Sorry. Okay, thank you, Sumin. Okay, delta should be decremented. So it goes beyond of the last one, so that is wrong. Okay, so let's try this again. Okay, so can you see that all the stack contents is printed correctly, and there's no trailing spaces here. So in this way, you can implement a forward iterator. And with the doubly linked list, you can also implement a backward iterator, which means that you may apply the decrement operator beginning from the end to the first uh, element. Okay. So, do you have any questions on this code? Any questions on the iterator? Okay, so if you don't have any question on this, let me reshare this. Today's problem. So today's problem is that this is just an explanation since the iterator is defined inside of the stack. If you want to use it in this outside of the stack, you have to use a scope resolution operator, which means that um, you have to use it with a stack with scope resolution operator, iterator. So if you want to implement print-like statement outside of the stack, you have to use this kind of type. Okay? Or with begin, you may use auto with begin. If you want to additional operators such as comparison with equality or plus, you may overload them further. So in my case, I just exemplified the plus for printing the last element in a smart way. So, but you may try this. Note that the iterator returning function begin and end should be defined as a stack method because this stack is a container. So the container knows which one is the beginning element and which one is the end element. So it is supported by the container element. Okay, so let's go forward to today's problem. Today's problem is implementing doubly linked list with insert and remove operation. And for inserted, insert an element E just before the position P. So P is something like a pointer. So you may implement it with an iterator, or you may implement it as just a pointer. And remove the element at position P. So it is pointing to a certain node. So that node is removed from the linked list, and you may disable the pointer. The element E is a node type, and P is a node pointer type. So you may implement node pointer as an iterator. So, but you may want, if you really want to E as an integer type, so you can do that for the current. You may choose anything will do. Node type or integer type, which is data type, is also okay for the implementation. For simplicity, you may add 2 additional nodes, the header and the trailer. So this is a very convenient way. Rather than the null node, you have a terminator node. Okay, so initially they are pointing each other. This is the next of the header, and this is trailer, and this is the previous node. Header node is the previous node of trailer. So if you want to insert something, then it is inserted before the position of the trailer. So you may insert this, and header next is adjusted. This is adjusted, and this is added. This should be added. Okay, so 2 additional nodes with header and the trailer is very convenient. So please use that. You may use this kind of implementation. So that is, the empty list contains at least 2 nodes, which is much like bound of the doubly linked list. So you may also implement additional methods such as prepend. So this is convenient for using that. So prepend E, which means that insert a node at the beginning of the linked list. Append E is making a node at the end of a doubly linked list. So if you want to do that, you just implement it. These nodes can be easily implementable if iterator method. These non-nodes, these methods can be easily implementable if iterator method begin and end are provided. So using this doubly linked list, implement an insertion sort. The insertion sort is an algorithm. The list is conceptually divided into 2 sublists, the sorted one and unsorted ones. So initially, the sorted sublist is a singleton list, and scanning the unsorted sublist, every element is inserted into the right place of the sorted sublist. Once the scanning is done, the unsorted sublist becomes empty, and the entire list is sorted. Given the 5 integers 19, 10, 8, 29, minus 40, so you may think about that the singleton list 19 is a sorted one, and this is unsorted list. So scanning from this first element, what is the right place, left or right of 19? Which one? Left one. Okay, so you are inserting this to the sorted sublist. Okay, so how about 8? You have to insert before 10 because you have to maintain the sorted sublist. So insert it just before 10. How about 29? You have to maintain this as a sorted sublist, scanning the correct location, less than, so 29 should be inserted at the end. Okay, how about minus 40? Since 80 is greater than minus 40, this should be inserted at the beginning place. Okay, so once the unsorted list is scanned, this becomes empty, and this contains a sorted result. So this is a simple algorithm to perform insertion sort. So note that your program should perform the sort in place. So you do not consider additional linked list, but you have to perform the sorting in place of the singleton linked list. So do you have any questions? Do you have any questions on the insertion sort algorithm? No questions? Okay, then I'll just explain the input-output format. So your program should read from standard input. The first line of the input contains a positive integer n, the number of integers, and the second line contains n integers separated by a space. So integers can be negative. So your program should print the result of insertion sort, the sequence of input integers in non-decreasing order. The input integer should be separated by a space. The output integer should be separated by a space. As a final note, your program should not print the no trailing space at the end. Okay, so can you see that there is no spaces at the end? No spaces. So you may adopt the previous technique of print. Okay. So additional requirement is that define and use the class iterator in doubly linked list with overloaded operators for assignment, comparison, and referencing and increment. And doubly linked list should support method begin and end, returning iterator objects in this case. Okay. So do you have any further questions on the problem? No questions? Okay, then you have about 25 minutes to go. Okay. So do you have any questions on the materials? No questions? Then you may safely go out. Let's call it a day and see you next time. Bye bye.